Hello everyone, let us talk about one more tool called Parquet. And what exactly is this? We have seen Avro, which was storing data in the form of objects, that to JSON notation. Now Parquet is a columnar storage format which stores the data, and I will show you how efficiently it is maintaining the column storage with an example. And columnar formats, they are attractive and they go for greater efficiency, and file sizes are usually smaller than row oriented equivalents. So I will show you the example. Might be storing a timestamp, for example, can be encoded by storing the first value and the differences between the subsequent values. This is one of the best examples to tell you how it is trying to save the space when it is storing the data. Say for example, for the first person, I have saved the timestamp as 10 o'clock in the morning. Next person, suppose they might have submitted the file at 10:10. I need not again write 10 o'clock, hours is 10, minutes is 10, AM or PM. I need not maintain that. Whatever is the first person's time is there, how far is the submission time of the second person? 10 minutes. So I will just write 10 minutes. So what does that mean? From the first person, the second person's submission time is 10 minutes later. Suppose the third person has submitted at 10:13. How do I write 13? So take the first person's timestamp, add the minutes, you are going to get the third person's timestamp. So you will not maintain the data completely again with hours and minutes, you are just going to see the delay between these two submissions and maintain, wherein it will try to occupy less amount of space while maintaining the data, right? And query performance is also improved because the query engine can skip over columns that are not needed to answer a query. You are trying to maintain it in columns, and whenever you are trying to access the data, it can skip over the columns which are not part of the query answer. Let us see with an example. Suppose I want to store client ID, name, address, mobile number, and the table name is clients. Say for example, I have 100 such clients and I am just showing you 2 clients data here, but consider in the table I have 100 clients. Any database which is using the concept of row oriented representation, just like SQL, Oracle, the data will be represented like this: ID, name, address, mobile number. So as I told, consider 100 clients are there, and here just I am showing 2 clients data. On the other hand, if we are using column oriented representation, all the IDs will be represented in one set, all the names will be represented in one set, all the addresses and mobile numbers should be represented in other sets differently. Now say for example, the point is we are trying to say column oriented representation saves time when you are accessing complete columns, right? Now my question is, say for example, I have a query on show the client names and their mobile numbers. How do we write in Oracle? Select client name and mobile number from clients. If this is the query and it is to be answered, we know Oracle follows this table representation. How many rows it has to contact? My query was client name and mobile number. Into how many rows did they span? 100 rows, because I was supposing there are 100 rows. So the query has to consult 100 rows in order to answer name and mobile number of all the clients. On the other hand, say for example, I have column oriented representation and the same question is asked to show me client names and mobile numbers. How many columns should I access? Only 2 columns, name and mobile number. Never I will access ID and address, whereas when I was accessing this I have to go through that, right, until I get mobile number. Are we saving the time? Definitely yes. When we are working with column oriented representations, they definitely do save time. This is the argument and we can definitely verify. Then The key strength of Parquet is the ability to store the data which has a deeply nested structure, and we are going to work with columnar fashion. And this is important since schemas with several levels of nesting are common in real world system. See, here I have just written the address like this. Can the address be again a nested structure? Definitely yes. Street number, column name, nearby landmark. Suppose I am trying to maintain all of them, again it will be a structure, right? So in such cases, whenever we have the concept of nesting, Parquet is the efficient tool in order to maintain the data. It uses a novel technique in order to store the nested structures in a flat columnar format with little overhead. I will show you with an example. And nested fields can be read independently of other fields, resulting in significant improvement. And where are we using this? Twitter, Cloudera, all these people are trying to use Parquet. And also whenever you are trying to work with, it works with the file format definition in a language neutral way, and implementations of specification for different languages, that is so it does not take care of which language you are going to use in order to access the file. It generally defines the file format in a language neutral or language independent manner. That is how Parquet files are being used in various places wherever we are going to have these kind of scenarios. Now, what are the data types I can use if I want to define my file? If you see how many types of integers are there, first anyways I have the boolean which is maintained as a binary value, and how many types of integers do we have? Int 32, all are signed integers only. 32 bit is there, 64 bit is there, 96 bit is there. Apart from this, float, two types, float and double, 32 and 64 bit floating point numbers. Apart from that, binary data type is there which takes care of a sequence of 8 bit unsigned integers. Apart from this, fixed length byte array is there which is always an 8 bit unsigned bytes. And whenever you are trying to define fields, if it is a group of fields, you need to mention whether the field has a repetition, what is the repetition level, is it required, is it optional or repeated. We need to mention with every attribute we are maintaining in the file. Now say for example, try to see simple Parquet schema for the weather record, wherein we are trying to maintain a weather record. In Parquet, every record which is similar to C structure, we use the word message. Instead of struct, we use here message, just remember like that. So we are using message weather record which has year, temperature, station ID. These are the three attributes. What did we write before that? Do I need to mention the year mandatorily or can I leave it? Can it be a missing value? What is this? Required. You cannot leave it empty. Similarly, temperature, required. Station ID, required. Say for example, the temperature values are repeated for a day. I am recording the temperature multiple times in a day. Required, comma, repeated. That is the next one. If you see, what are the levels of repetition? Is it required? Is it optional or repeated? So in my example, if temperature is recorded multiple times a day, what should I do? Can I leave it? No, it is a required value. Required space repeated space int 32 temperature. That is how I need to give the definition of the record. And notice that there is no primitive string type. If you see the data types, do I have any string data type here? No. So notice that there is no primitive string type. Instead, Parquet defines logical types that specify how primitive types should be interpreted. So if there is a separation between the serialized representations and the semantics that are specific to the application, what are we trying to do? Strings are represented as binary primitives with a UTF-8 annotation. Whenever I want to talk about strings, I go for this. I say string is following UTF-8. Whenever I write UTF-8, you should understand it is going to be the primitive for representing the string data type. Now try to see this one. Here I will write this way. I want to define a list. What is a list? An unordered collection of values, and it is defined like a group. How are we defining group? If you see message M, and it has how many attributes? Group A is there, which is again a list, which consists of a group called list, which has an element which is of integer data type, 32-bit integer, and it is required, and the group value is repeated, right? Similarly, unordered collection, map is an unordered collection. In case of map unordered collection, what are we trying to do? It is a message M, it is a required group, and group name is required for a map, yes. And do I have a repetition of key values? Yes. Do I have values for them? What is the data type for values? Suppose in my example I want to define them as a string. Do I have, I want to define keys. What is the data type for keys? Keys is the string data type. How do I define? It is a required one, key is required, binary data type, which following which format? UTF-8. Similarly, what is the value? Value may not be given for a particular key, so it is optional, which is taking integer data type value. So whenever I want to talk about strings, the concentration here is on representing strings. You need to take this format for representing strings. One more way of representing a Parquet schema. How do I write? I go for a GUI based representation wherein I select first name, which is of binary type. If you open through this, these are the properties. You can see the properties of this. First name, type binary, logical type is UTF-8. The moment you see binary UTF-8, you can understand it is of string data type. And repetition level, if you see repetition level, optional, repeated, required, 3 levels will be there. Compression, are we going for compressing it or not? So you can talk about various types of properties that can be set while representing the data. Either you can write descriptions in a text format, or if you are using a GUI based dashboard, you can try to talk about the properties of the items like this. And very important with respect to your interview questions or your theoretical examination questions, Parquet file format. So I will just show you first, then I will talk about this one. This is how the Parquet file row group will be there. So I will just talk about this one. A Parquet file consists of a header followed by one or more blocks terminated by a footer. Now try to understand what are the 3 parts: header, one or more blocks, footer. 3 things are there. Now the header contains only one thing. What is that? A 4-byte magic number. Please remember, every header of a Parquet file contains a 4-byte magic number. What is the magic number? 4-byte. PAR1 stands for, it's a Parquet file and you are in the header section, PAR1, right? Why it is 4-byte? Every character occupies 1 byte. So PAR1, which identifies the file being in Parquet format, and all the file metadata is stored in footer. Now try to understand what are the three portions of the file: header, blocks, footer. What is there in header? PAR1. We call it as the magic number for the Parquet files. Just by seeing that, the system identifies the file is in a Parquet file format, right? PAR1 for every Parquet file, that will be the magic number. Then who is containing metadata about the file? The footer is containing metadata of the file, right? So all the files metadata is stored in the footer. The footer's metadata includes the format version, the schema, any extra key value pairs, and metadata for every block in the file. So maximum metadata is spread to footer, which consists of what is the file version and what is the schema definition of the file, any extra key value pairs are there, and every block's metadata. The final two fields in a footer are a 4-byte field encoding the length of the footer metadata and the magic number, again PAR1. So after writing everything in the footer, the final two fields, what are the final two fields we are writing? One is a 4-byte field encoding length of the footer metadata. The length of the footer's metadata is maintained as a 4-byte field, which will say what is the length which I have written in the footer. Apart from this, what is the magic number again? PAR1. How many bytes it is going to occupy? PAR1 will always occupy 4 byte. So if you say last two fields in the footer, they are taking 8 bytes, in which last 4 bytes are the magic number PAR1 and first 4 bytes are the metadata length. Please remember this. And the consequence of storing the metadata in the footer is that reading a Parquet file requires an initial seek to the end of the file minus 8 bytes. Are we understanding? Till where should I read? Initial seek requires, so storing the metadata in the footer requires an initial seek to the end of the file minus 8 bytes. End of the file for this Parquet file is defined end of the marker minus 8. Why that minus 8? Because in the footer, what are the last 8 bytes? Last 4 bytes is the magic number, next 4 bytes is the length of the footer data. So you are skipping that 8 bytes and rest of the initial seek is done on the metadata axis. Then a second seek backward by that length to read the footer's metadata. So this is how you are trying to do. Unlike sequence files and Avro data files, where the metadata is stored in the header and sync markers are used to separate the blocks, Parquet files don't need sync markers since the block boundaries are stored in the footer metadata. So other files like Avro and all, they are trying to store the metadata information in the header itself. So if I want to access the data, I need to pass through the header, then only I can access the actual data. So here we are just taking the information from the footer, and for every block sync markers are not needed because that magic number itself will tell me where it is ending. So this is how it will be. Header, blocks, footer. What does a block contain? Only column chunks, nothing else, no sync markers, nothing. Again, every column chunk will have pages of data. So this is the description for what each row group is storing, what each page will be maintaining. And most of the time Parquet files are processed using Pig, Hive, Impala, etc. So, out of which we will be generally working with Pig and Hive as part of our curriculum. So, if someone asks you how a Parquet file is different from Avro, maybe you should be talking about both the file formats and give the differentiation between these two formats. Thank you.